Welcome to today's lesson on exponential graphs. From the Desmos activity, you should already know about the basic shape of exponential graphs. We've got two examples here. The one on the left is 2 to the x, and the one on the right is 2 to the negative x, which is actually the same as 1/2 to the x. Notice that when the base is greater than 1, as in 2 to the x, the function is increasing as we look at it from left to right. And when the base is between 0 and 1, like the one on the right, our function is decreasing. Now you might notice something else about the graphs. On the left, we basically have the parent graph y equals 2 to the x. And on the right, we've got y equals 2 to the negative x. Well, a negative in front of x, as you know from your transformations, causes a reflection over the y-axis, which is exactly what we see here. Example 1, let's graph f of x equals 2 to the negative x minus 3 using transformations. First, we want to graph our parent graph, which we just saw above, which looks like this. I've just graphed 5 key points on my parent graph. So this is 2 to the x. The next thing I'm going to do is I am going to deal with the negative. Now we know that a negative in front of x in the function causes a reflection over the y-axis. So that means I will graph my reflection over the y-axis, which looks like this. So this is 2 to the negative x. And then we know that a minus 3 causes a shift down. So every point on 2 to the negative x, I'm going to move down by 3 points. So 1, 2, 3, 1, 2, 3, 1, 2, 3, here and here. And so this here is going to be y equals 2 to the negative x minus 3. Now let's just take a look at the domain and range. Because it's an exponential function, the domain is still going to be all real numbers. But because this graph got shifted down 3 units, the range is now y has to be greater than negative 3. Example 2. For the following exercises, match each function with one of the graphs in figure 12. So as you can see, some of the graphs are increasing and some of them are decreasing. So let's look at which ones would be increasing. On number 13, because the base is between 0 and 1, this has to be a decreasing graph. For 14, the base is greater than 1, so this will be increasing. For 15, the base is less than 1, which makes it decreasing. 16 has to be increasing. 17 is increasing. And finally, 18 has to be decreasing. So now let's look at our 3 decreasing graphs. The decreasing graphs are A, B, and C. Now of those 3 graphs, 2 of them have a y-intercept that's lower and one has a y-intercept that's higher. So when we look at our equations, some of these functions have a multiplier of 2 and some have a multiplier of 4. So the graph that passes through the higher intercept must have a multiplier of 4 in front of it. So when I look at my equations, the only decreasing function that has a 4 in front of it is 18. So that means that 18 has got to be C. So now we have to compare A and B. They both have the same y-intercept, but one is steeper than the other. We'll keep in mind that the smaller the base, the larger the values will be when x is negative. So when you look at number 13, which has a 0.69 base, that's smaller than the 0.81 base for 15, so that means that 13 has to be the taller graph, which is B. And that means then that 15 has to be the shorter graph, which is A. So now let's look at our 3 increasing graphs. Only one of these has a higher y-intercept, so let's find the one that has a 4. So the one with a 4 is 16, so that means that 16 has to be D. And when we compare 14 and 17, when x is a positive number, the larger base produces the higher values. So that means that the one with the base of 1.59 has to be the taller graph, which is E, and the one with the base of 1.28 has to be the shorter graph, which is F. Example 3. The graph of f of x equals 3 to the x is vertically stretched by a factor of 2, reflected across the y-axis, and then shifted up 4 units. What is the equation of the new function g of x? State its y-intercept, domain, and range. All right, so if it's stretched by a factor of 2, that means that we have to have a multiplier. So that's going to be 2 times 3 to the x. If it is reflected about the y-axis, that means that we have to put a negative in front of x. And then finally, shifting up 4 units means we have to add 4 to the end of the function. So that means then that g of x is 2 times 3 to the negative x plus 4. And then we want to talk about its y-intercept, domain, and range. Well, we know that the y-intercept is when x is equal to 0. So if we evaluate g of 0, we get 2 times 3 to the negative 0 plus 4. Well, 3 to the 0 is 1, so this becomes 2 plus 4, which is equal to 6. So that means that the y-intercept is the point 0, 6. The domain of any exponential function has to be all real numbers, but since the graph has shifted up 4 units, then the range, which should normally be y is greater than 0, has to become y is greater than 4. Example 4, describe the end behavior of the graph f of x equals 3 times 1/2 to the x minus 2. So we have to think about what kind of transformations are happening to our basic graph. We know that the 3 is a vertical stretch of 3 units. We know that the base equaling 1/2 means we're going to be decreasing instead of increasing. And then the minus 2 means that we're going to shift down. So let's think for a minute, what would be the y-intercept of this graph? So that would be f of 0 is equal to 3 times 1/2 to the 0 minus 2, which is 3 minus 2, which is equal to 1. So if we sketch this graph, we know we have a point at 0, 1. We know it is decreasing and it has shifted down by 2 units. So instead of having a horizontal asymptote at y equals 0, it's going to be at negative 2. And so our graph is going to look something like this. So if we had to talk about the end behavior, we could say that as x approaches infinity, that's the right side of the graph, y is approaching that horizontal asymptote of negative 2, so y approaches negative 2. Now on the left side of the graph, as x approaches negative infinity, y is going up, which means that y is approaching positive infinity. That's all for now. Thanks for watching.